I will shut down my YouTube channel by the end of June next year. Once again, I will shut down my YouTube channel by the end of June next year, year 2023. From C++ 17 2023 CUDA SQL OpenGL this playlist, scroll down, you can find our previous episode, episode 139. We learned how to use posterior, also create sequence, show more, download source code link, show in folder, unzip it, rename 140, copy this folder, paste it in your working directory. Please notice I have source code from previous episode, but I don't have source code prior to 119. To create new files, I have to delete my source code of the previous episode. I can simply copy and paste from my previous source code instead of downloading from this video. The reason I download source code by using this link is that sometime later when I watch my current video, I don't know where to get the source code of the current episode. I downloaded this source code not for the audience but for future Thomas Kim. Now start Visual Studio Code. Open CPP 17 2023 parallel. Select folder 140. Click this button. 7. Signed int.cpp. Hit enter. Ctrl B. Include CPG, SCD extensions using namespace CPG types. Never ever do this. Instead, namespace CPT CPG types define namespace alias. We want to create a function that evaluates the difference of two numbers and its absolute value. Auto difference, auto A, auto B, or we can put constraints CPT arithmetic C. It can be forwarding reference CPT arithmetic C forwarding reference. Return A greater than B, then A minus B, else B minus A. Void test failed difference absolute. Int main, copy this function, paste it here. Now I will introduce using namespace CPG literals. If you are going to use namespace using namespace declaration, never do this. Never use using namespace declaration in the global scope. Always limit the scope of using namespace declaration. Or result, we are calling this function. We pass -2 1 SED cout result type result cpg enter. Now open up your C++ compiler cd 140 advanced recursion dir dp cpp ehsc qsed C++ training fno SQL 7 signed int.cpp or d.exe, hit enter. So this is command string. Copy, paste it here. As of today, this command string seems obvious to me, but by the time I watch this video, it's very likely I have forgotten this command string. Now cls dir d. So the difference absolute is 3. It works correctly. Now the problem occurs unsigned. Right click, go to definition. Here we can find where is unsigned integer. Short, unsigned short. So I will create for unsigned integer. Copy, paste. Unsigned. Then return type should be unsigned int. Copy, paste. Now here it now works because we defined custom literal suffix. Now we build again. clsd. Now it is garbage. So this function failed ruthlessly. This function failed ruthlessly. How can we fix this problem? Correctly implementing such simple function requires much more deeper knowledge. I copy and paste it. I will change the name difference absolute. Also, I will remove reference because we constrained our argument A and B to arithmetic types. By arithmetic types, I mean character, unsigned character, signed character, int, short, etc. Most arithmetic types are less than or equal to 8 bytes, such as double. In such case, using L-value reference or R-value reference or forwarding reference obstructs C++ compilers optimization. Also, cache usage. So I removed reference. Also, this function does not need to leak exception, so no except. It can be also used at compile time, so context per. With such things, using AT 댓글 type A, using BT 댓글 type B, if context per LCD is unsigned B, A, T, and LCD is unsigned B, B, T. When both A and B are unsigned integral type, then we can simply return this expression. Else, using signed AT LCD, make signed T AT, copy paste signed BT BT. Then we take common type using signed T LCD, common type T. Then SAT SBT. We created common signed T of A and B. Then auto AA signed T A, copy paste BB signed B. Then we return this AA BB AA BB BB AA. Now copy this function, paste it here, overwrite, copy this function, paste here. Now scroll up, we will change it to new line. Also here, new line. Now we build again. CLSD. In our previous case, test failed difference absolute. We failed. Now, in this case, difference absolute, we succeeded. The arguments are negative 2 of type int, 1 of unsigned int. Now it seems working properly, but this is not yet perfect. Okay, this is not yet perfect. Copy, paste. Now 2.5. It should be 2, 2, 2, 2. We build again. It does not build. The message says at line 40. At line 40. Because when A is floating point type, we cannot use SED make signed T. In such case, if context for SED is integral B A T and copy paste BT, then we have to do like this. Else we can do this. Now let's try it. CLSD. Now it works. Okay. In both cases, in this case, both are integral type. In this case, one is integral type, another is floating point type. Now, in all cases, it works. But this is very ugly. This is really ugly because the same code is repeated in two places. Even if we fix our code like this, it is still very ugly. Now copy this. Paste it here. Difference absolute. Better. Now here we don't need this. Instead of C++ standard library, I created CPT command signed T. Now AT PT. Also, we don't need this. We can fix very clean code. Compare this implementation with this implementation. It is failed. This implementation is failed. With this, copy, paste. Result 3. Difference absolute. Better. Then 3. 3. Copy, paste. I will change it to L. Then here 4, 4, 4, 4, 2, 1. Now we build again. CLSD. So our new implementation, difference absolute better. works perfectly. Please note that I used CPT command signed T. Right click, go to definition. This function calls make signed T. Here, right click, go to definition. So, in this part, we implement make signed T. Through this implementation, we make signed T. Using this make signed T, we create common signed T used in this function. Most of us are not yet familiar with modern C++. Please understand that we calculate absolute value of the difference of two arguments. It should be extremely optimized because it is used in the numerically intensive calculations. For optimization purpose, I used keyword auto, not L-value reference or R-value reference, to improve cache hit. As long as either A or B is of type floating point, we don't need this code, so we can optimize like this. STD is a floating point A, T, or copy this BT, or both AT and BT are unsigned type. This is our final implementation. At runtime, this code does not exist. Also, this code does not exist. Either this code or this code. Only one of this code or this code exists. This function should be extremely optimized. I do not concern myself about the performance of std cout or std string stream. We use these things to print out to console. We rarely use these functions or objects other than debugging purpose, but this function requires extreme performance because we have to evaluate absolute value of the difference of two numbers in numerically intensive calculation. This is our final implementation. Perfect. I created all my libraries as I explained. I rarely use inline keyword, but in this case I used inline keyword. Also, I used no except to suppress stack winding code for exception handling. Also, keyword auto for cache friendly optimization.